Hello, my name is Sharifa, and today we're going to be taking a look into Snell's law. But first we must define what refraction is. Refraction is the bending of the path of light wave as it passes across the separating two mediums. As you can see here in this image, we can see the light bending as it crosses from air to water. The amount of refraction depends on properties of the two media on the angle at which the light strikes the boundary. With refraction comes the index of refraction, which is a dimensionless number that describes how light or any other radiation propagates through that medium, or also described as n equals the speed of light in a vacuum over the speed of light in the medium. As you can see here we're going to define the variables. N equals the index of refraction, c equals the speed of light in a vacuum, which is 3 times 10 to the 8th meters per second, and v equals the speed of light in the medium, with the units of meters per second. Here are some common mediums with their index of refraction. The most commonly used mediums are air, which has an index of refraction of 1.003 or 1, and water with the index of refraction of 1.33. For example, with that equation of index of refraction, we have c equals 3 times 10 to the 8th meters per second with a v of 2.5 times 10 to the 8th meters per second, and we're going to try to find the index of refraction. So first we must place the speed of light in a vacuum over the speed of light in a medium, and then we can get our index of refraction, which is n equals 1.2. So now we dive into Snell's law equation. So the Snell's law equation is n1 sine theta 1 equals n2 sine theta 2. N1 equals the index of refraction for the first medium, theta 1 is the angle of incidence, N2 equals the index of refraction for the second medium, theta 2 equals the angle of refraction, and theta to the first power equals the angle of reflection, but for our specific problem we're not going to be using that. So the angle of incidence is the angle that a ray makes with the perpendicular to the surface at the point of incidence. The angle of refraction is the angle made by a refracted ray with the perpendicular to the refracting surface. Here is a diagram with the variables used in Snell's law. As you can see here is the index of refraction for the first medium, and here's the index of refraction for the second medium. And here is our incidence ray with theta 1, and our refracted ray, theta 2. And here is a reflected ray with theta raised to the first power, but for our problem again, we're not going to be using it. Now, here we are to our problem. The problem we have is light travels through a material with the angle of incidence of 50 degrees. If the angle of refraction is 38 degrees, what is the index of refraction for the material? So here we must draw the diagram first. By drawing the diagram, we can see the problem more clearly and answer it more effectively. Here is our index of refraction for the first medium, and here is our angle of incidence for the first. Here is our angle of incidence, and here is our angle of refraction. But now we must find the index of refraction for the second medium. So our givens. So n1 equals 1. So we can assume that the medium for the first we can assume that the index of refraction for the first medium is air. And so our theta 1 is 50 degrees, and our theta 2 is 38 degrees. And now we must find our index of refraction for the second medium. So the equation we must use to find our index of refraction is Snell's law, which is n1 sine theta 1 equals n2 sine theta 2. So now we must plug in our numbers. So here we can see we plugged in our index of refraction for the first medium as 1 right here, and we put sine, and here is our angle of incidence, which is 50 degrees, equals, since we don't know what n2 is yet, we're going to leave it like that, sine 38, which is our angle of refraction. Now we solve. But first, make sure your calculators are put in the mode of degree. So with that, type into your calculators 1 sine 50. And with that, you can get 0.766. And then you also type into your calculators sine 38, since we don't know what n2 is yet. And with that, you can get 0.616. And in order to isolate the variable n2, divide 0.616 by both sides of the equation. And with that, you conclude with N2 equals 1.24. So, with the index of refraction of the first medium of 1, and an angle of incidence of 50 degrees, and an angle of refraction of 38 degrees, our index of refraction for our second medium is 1.24. Thank you.